This is the second paper of the Int 2 exam, done very quickly, so I hope there's no silly mistakes, but I'm sure you'll spot them if there is. So the first question is the multiplying out brackets, expanding brackets, x plus 2x minus 5 minus 9x. We multiply out the bracket x squared minus 5x plus 2x minus 10. You leave the minus 9x there, but you gather like terms. And so you've got minus 9x minus 14x plus 2x gives minus 12, and we end up with this answer here. Second one, we've got to find when the value reduces to half 750,000. So half 750 is 375, so we're watching for that. And all we do is each year depreciate it by 20%, so the multiplier is 0.8. So we go like this, and it's after 4 years that it decreases. So that would be the answer, and you would show working of that sort. The next one is construct a pie chart, which is unusual, but there you are. Construct a pie chart. So the thing is to get the angles, that'll get you a lot of the marks. 35% is 30, obviously percent, so they add up to 100. 35 over 100 times the angle to find what angle to give to each element. Labour's 30%. And so you get the angles 126, 108, 54, 36, 36, and then you should just draw an appropriate pie chart and label each sector with the party, and that would get you full marks, hopefully. Question 4 was the cosine rule. SSS, I thought it might be length of side, but it was angle they wanted. And they want this angle, so it's that squared plus that squared minus this squared. There's the working there over 2 times 9.3, 14.2, and you just work that through. I mean, you can pause it if you want to check, and I got 34 degrees for that one. The next one, because it says to 1 decimal place, you know it's the quadratic formula. You get A is 1, B is minus 5, C is minus 2. It's minus 5, so that's one of the errors I hope you didn't make. You put a 5 there. And then the other point is that C is minus 2, so when you multiply this, you get a plus 8. And of course, minus 5 squared gives you a plus. So you end up with 5 plus or minus root 33 all over 2. And you work through to these two answers here, hopefully. 5.4 and minus 0.4. The next one was the good old standard deviation, which I hope you all picked up full marks on. So you get them, you add them, you get the mean, you take the mean away, you square that. These are always positive. Add that up, you get 50. Square root of sigma x minus x bar squared, which is just 50 over n minus 1, which is 4. You end up with 3.54. And then the second part, if you look, he scored exactly 20 more at each hole, so his mean just goes up by 20. He didn't have to work it all out. That's what happens. But if you did work it out and you got the right answer, you'd still get the mark. The main one is that the standard deviation, because the pattern is the same, the standard deviation is exactly the same. It's just shifted all the scores up. The next one is the old take a volume and change its shape and work out one of the parameters. And the only wee trick they put in is that you lose 10% when you melt the cube. So first you work out the volume of the cube, you lose 10%, then you find the volume of, you express the volume of the cone in terms of its radius and h, the height that you're trying to find. So that gives you 1/3 pi r squared h, 1/3 pi 64h, which 1/3 pi 64 gave me 67.02. So the volume of my cone is 67.02 times h, and that just equals 900. So you divide 900 by that to get the height of the cone, 13.4 centimeters. Number 8 is change the subject with a square term. So we take the c over, get a minus c equals 3b squared, divide by 3, and then we have to take the square root, so that's your final answer. And this one here, we've got, if we look at the x terms first, we've got x over 6, x to the power 6 over x cubed, subtract the powers, you gives you x cubed on the top. Y cubed over y squared gives us a y, so the final answer is x cubed y, which I hope you got. This one is one where we have to use a couple of things. We've got to try and find this height here that's remaining. We know this is in a right angle triangle, but we only know one angle, so hopefully you said we need to get at this side here, and this side here we get from triangle SCT here, STC, because we know that this angle here, we can work it out, it's 90 minus this angle, so it's 90 minus 12 plus 38, which is 40, so we know this is now 40, and we can apply the sine rule to this top triangle. X, the thing we're trying to find, because we'll use that in the next part, x over sine 40 equals 4 over sine 12, the side and the angle opposite. So x equals 4 sine 40 over sine 12, which I got to be 12.55. And then when you know that that's 12.55, you look at this triangle, and we'll call this H. And so that's what I called H there. So sine 30, oh, I've made a mistake. Have I used sine? No, 38, that's right. Sine 38 equals H over what we just found, 12.55, so H is 12.55 sine 38, which gives me 7.05 meters. Getting there. Now, algebraic fractions, different denominators, we multiply the top and bottom of this by this denominator, and the top and bottom of this fraction by this denominator, x plus 2, that gives us a common denominator here. And on the top we multiply out the brackets, 3x minus 3 plus 5x plus 10, gather like terms, 5 plus 3 is 8, 8x plus 7 over the common denominator. And that gets us those marks. Getting there, speeding up, but we're getting there. This one here is the good old tunnel oil tanker. They've come up with a new one. We have to find this height, but essentially it's the same problem. We draw this down here and create the triangle ACX. I'll call this X. AX is the midpoint by symmetry of this chord. So we're given that this is 30, so AX is 15. So in this little right angle triangle ACX, I know AC is a radius, which I'm told is 24, so I can say that CX is going to be CX squared is Pythagoras minus 24 squared minus 15 squared, which works out at 18.7. And then the height I want is just PC plus CX plus XD plus DQ. And I now know all those because PC is a radius and DQ is a radius. And then CX equals XD 18.7. So I just add them all up to 85.4. And then we come to the last one, the Ferris wheel, which is really just a way of giving us a trig equation to solve. So we're looking for t when h is 10.8. We put 10.8 in the equation and we move it around to make the sign the subject. So take the 7 over, gives us 3.8 equals 5 sine t. Sine t is 3.8 over 5. I'll look up the reference angle as 54.96 degrees, but I'm dealing with a sign that's positive, so I tick these two. My other angle is 180 minus, so it's after 55 seconds and 125 seconds. And that was a speedy journey through paper 2, and I hope you all did well. Thank you.